Hey Dr. Dong, this is Josh Adams. I'm doing my project on the language R, and I want to show you how to get it set up first of all for Windows. A lot of this is documented in the Word document, the setup guide that I made, but I'm just going to go through it with you again real quick because it's fast. So I have a link to this URL in the document, but it'll take you to the IDE I was using. I'm too far ahead, so it'll actually say this is the first page of the URL takes you to, and here's the different OSs you can choose from. Obviously you'll click Windows, and then you'll want the base version, install R for the first time. It gives you the IDE and the language itself, and then you can click this one here, and that'll essentially start an executable file download, which you'll click on and install it in your machine, and it'll even drop a little shortcut on your desktop if you want, and it just looks like this. It's an R with a circle, and that's how you get into the IDE, which I'll show you right now. And once you open this up, I haven't touched anything, and you just open it and you drop right into this R console, which is just a console for interacting with the R language, and you can enter any scripts or whatever and blah blah blah. Anyway, yeah, they don't know what that is. Anyway, I'll get to this when we run the program, but I just wanted to show you. I think I changed the colors, so it might be all white, but this is what the IDE looks like. Now I actually wrote my program in just another text editor, and that's how I think you can probably write it in this if you wanted to and save it, but you have to, I'd rather just use a text editor and load it from here. I'll show you how to do that when we get there. So I used just a regular, one of my favorite text editors, and it happens to have some helpful text highlighting for different types of syntax and stuff. I know this is Macworld, but it should translate pretty well. So anyway, this is the program. And I want to preface this with saying that the R language is not super set up to deal with object-oriented style programming. It's a scripting language that handles big data and matrix manipulation and mathematical functions very quickly. It can do computation really fast, so it does have some object-oriented capabilities, but it's not what it excels at. So some of this looks really weird, but we did it anyway. It's interesting. So the first thing I did here was make the student class, and this is kind of a common theme in the R language. Is you call any sort of method that's in the language. The syntax is kind of Python-y. It doesn't have semicolons, or it's easy to write, and you don't even have to put var or anything. You just put a name. And I'll show you. You can use equals. The primary assignment operator, I guess, is this arrow, and I think there are some minor differences between equals. You can pretty much use them interchangeably, but there's a couple things that need this. The language prefers you to use the arrow, so but I used equals up here, and most of the time it translates. If it doesn't, then you use the arrow. Anyway, so here's this student class, and oh yeah, like I said, this is the common theme is method, open parentheses, and then a really long stretch of optional parameters, and a lot of them have default values, so you can just leave them out and the system will take care of it. But some of the methods are just crazy. They have like 19 parameters that you can just put in. Some of them are booleans and they have real weird names. So it's heavy. I was in the documentation pretty often trying to figure out how to do some stuff, but it was weird. Anyway, so this is just to set up a class. There's a method called setClass. You name your class. The second parameter I used was representation, and this is where you would define your properties for your class. And these orange ones are just the name of the property, and then the yellow here is the type of the property. Numeric would translate to integer, and then character would translate to string. and that's pretty much all I used for the different types of data for the student class. And I believe they're initialized to the NA value. I didn't give them a default value or anything, so they should just come out uninitialized, which we'll do later. This is the method. The get letter grade method is what I called it, and they do methods really weird. Functions are pretty easy. You can just name your function equals function and then your parameters, and then do all your code here, and we'll get to that one in a minute. But methods are weird because you have to tie them to a class, so it's actually a two-step process. The first thing you want to do is, I believe you don't have to do this, but this is standard again for the language. You set a generic version of your method, which can then be, now since I only used it with one type of object, my signatures match, but the idea is to be able to set a generic method, say area, say you were doing shapes and you wanted to do area on a triangle object or a square object or a circle object, and you wanted it all to have their own implementation of that area method. Well, you'd set one generic named area, and then you could tie it to use a standard generic thing called, I don't think these parameters matter, but you use standard generic and then rename it, and then down here you'll do set method, and again it's weird syntax, but you make sure that these all these names match, but then this signature here is what denotes what type of object that this implementation is for. So, say I had another class called person, I could do another set method down here with the same style of parameters here, but have signature equal to person and do a completely different implementation. So I think it's kind of weird because I tend to, I don't know, usually I would just call it area of circle or area of triangle and just not have this ambiguity here, but if you want to, you can. So two-step process. So you set generic for get letter grade, tie it to the set method of the same name, again tie it to the student object, and then the definition down here is where you actually get to use your parameters. And methods always they expect the type of object that they're tied to be passed in as a parameter. And so I'll show you more later, but since it's a pass, there's not really, I think that there's like a cheating way to pass by reference, but it uses some things that aren't inherent in the language, so it's pass by value, and I'll get to that later. But they want you to pass in the type of object that the method refers to and then be able to return it later after you manipulate it or recreate it or whatever. Anyway, so this is the get letter grade function. Pass in the student object and then the total points, so that you can just do your basic if-else ladder. That there's not a easy way to, you can't do ranges in the switch statement. I looked for a long time. It's just single values. I'm gonna make this guy calm down. Oh, leave me alone. Okay. You can't do ranges in your switch statements, so I used an if-else ladder to assign the appropriate letter grade. And basically what I do down here is set that property of the student object, the appropriate grade, to that and return that actual object. So what's happening down at the bottom is pass in the current object, a copy of it, assign the value, assign the correct grade value, and then return it back to whatever I was doing down in the main version, quote unquote main version of the program, and just reassign. I'm reassigning it. I'm passing in an object, setting the grade, and then passing it back, and then it's reassigning it later. I did make a regular function just to handle the rest of the values. Let me come back to this because this actually happens at the end, so I'm going to come back to this function. But I just wanted to put a function here to show you function versus method and how easy they are, or how different they are, and easier I think it is to do functions. Okay, so essentially there is no main, it's just a script. So whatever's not enclosed with some sort of function or whatever is just going to execute as if this is the beginning of main or whatever. So the first thing I do is ask for the file path for the scores file, and you just use a readline method and put it right into a variable, which again you don't have to say var or anything, you just name it and there it is. And so again, that's why I like the color helpers in this text editor. And then this is where R really shines. Once I get the name input from the user here, there's this function called read.table, and again, this is another bunch of weird parameters. I won't go into too much detail, but you have to do some distinct settings to get this to read in correctly. And so basically you read in the file, and it immediately prints, or it immediately stores in, it makes a matrix essentially of all the values. And like header true here, for instance, will, that top line is just the labels for the data, so that will go ahead and treat those as labels and get rid of them, so it knows I don't want to use those for the main data, I want to put those as headers. So that's cool. And then it's gonna try to do, it does a lot of stuff behind the scenes. So most of the data from that scores file was all numeric, it was all numbers, so it's gonna just immediately convert everything to numbers and say I've got a matrix here. Okay, maybe I had to put check names was false because the first column's weird, right? It's C and then a bunch of numbers, and it's gonna freak out and say, well, here's an integer with the character at the beginning, so I'm just gonna, if we were checking the names, it would error out, or it would get mad for whatever reason. So you taught not to check the names and just take the value for what it is. But since all the rest of them were numeric, it sets all the values to numeric. So it took me a while to figure this out, but even though that first data has a C on it, it still treated as numeric. So the next thing I wanted to do was say, hey, that first column in the data with the C numbers, that needs to be a character. So you just use an as character, and then you can say input data is what I'm calling this table that I'm using to do the calculations. You say the table, so it's as character from the table, and then row, and then column. You can use a bracket notation of row comma column, so if you leave that off it doesn't matter. So basically this is saying just get column 1 and set that as all characters. So that was giving me trouble because I was on the associative array part later, and I'll get there. Okay, so we have our data read in. We've set the C numbers to strings types. Everything else is numbers, which is all handled by the system. It's really nice. And then we want to, so what I did is actually add some rows to the table, because I used this big table, again this is what R shines in, to manipulate all of the data. And let me just pull up the scores text. This might be, so yeah, so again this first line is going to be treated as labels, and then here's all the data, right? It's just numbers. Set this first column to strings. So we end up with this matrix of all these numbers here, and that's where R is really good at doing calculations. So okay, so let's see. Right, so I went ahead and in one line here I create another row. I'm sorry, this is just like a list essentially, or an array or whatever, and I called it total points column. So this is going to append to the table later, but basically you can just do row sums of everything. I have to do a -1 here on the input data, so that ignores the C number column. And let me do this real quick. So that ignores the C number column, and it just gets the sum of all the rows and ends up with a list. Like say there's another, just right here, another list of all these 1, 2, 3, 4, 5 I'm sorry, that's columns. However many these are, sum of each one of these minus the C number will go down, so you end up with this extra column here. It's not appended to the table yet, but it's there. And so then I'm actually going to create here the total points column header. I'm gonna name it total points, so it's an empty column. Here's that null value I was talking about that's NA. It's just setting all the values initially to NA. And then I'm gonna set that new column, which you denote by table $ column name equal to the row that I created, or the sum of values. And so it basically takes the sums and appends it as a column. Then I'm going to do the same thing with the letter grade, add an empty column there, which, again, we'll need to run that method later to get these. So, but right now it's total points is another column. So just envision total points coming next, and then letter grade here, and total points will already be calculated. Letter grade will be all NA. And then you wanted an associative array to store the student objects. Now that is just a list in this R language. You can still do key value pairs this way. So I create an empty list called student list, and then I use a good old for loop to go through each one of the rows, because I'm going to process all of my data by each row, because each row is essentially a student, right? So I start I in 1 to the number of rows, so start at 1 and go to for each row. Create a new student object. That's how it's kind of like Java, new with the name of the class. And then I'm using I as the row number, but I hard-coded in the column values because I know which one each one of them is. So each one of these is a property of the student object, right? So I set the student ID, which is the M number, as row I, column 1, and then CLA score, LA score, quiz score, blah blah blah, row I, and then each subsequent value. So total points, like I said, has already been calculated for us. But now, after column 7, we need the grade. So what I'm going to do is take the student object that I created and pass it into that method that I created, which I told you we pass in the object by value. So it sends a copy of this current object with all these. And then the total points was the other parameter that you used to figure out the grade. And then that's going to come back with the same object that has the letter grade inserted. So I just assign that student object with the grade to the one I'm already working with here, and then like I said, I'm still keeping this table in data, which when I show you I printed, it just looks nice. So I went ahead and inserted, I want to populate the letter grade column up here, which is still all null essentially, or NA. I want to populate that as I iterate through the list too. So after I've gotten that letter grade into the object, I'm going to go ahead and take that letter grade from the student and put it in my table, just for a pretty output later. And then this is when I actually add it to my student list associative array. So student list, and then the double brackets is where you can assign the key, and we want the key to be, it happens to be the student ID property, or the M number, and then the value going in there would just be that object I created. And so it's going to iterate and create all those students, each one, and end up putting them in the list, assigning the letter grade to the student object, assigning the letter grade to the table cell essentially, and then we're done after that. So we're doing all the processing here. And we're going to ask for 2 inputs. I say please input C number of the student you wish to view, and again read line gets that into this variable CNUM input. These write lines. It's funny. I use print for a lot of stuff, but when you want to print just a new line character for spaces, you have to use this write lines method, because print function behaves differently. Anyway, just for spaces I use write lines, and then And then I'm just going to print, but see, for print, you can just print the contents of an object very easily. You do with print, but can't do a new line character. It freaks out. It's real weird. So print student list, which is my associative array, with the again, this is how you denote a key. Get the print the object. A key is in double brackets from the input received from the user, and then so that's pretty standard. So it'll print that object, and then ask again for another one. Do the same thing. Reassign that variable. Print the next one, and then I just say here's the rest of the students. Print the entire list, which will print all the objects, and then I say here's a table representation of all the students, which is that table I've been maintaining. So what I want to do is contrast the object-oriented version of R to the what R excels at, which is matrix and table data. So I print that out. I'll show you that at the end, and then I'm going to call that function that we need to go back to called calc extra info. Pass in the table again. Okay, actually that is wrong, so sorry, forget that I did that. I'm calling it twice, so this is gone. Some on the fly editing here. So I just printed the whole table because it's table representation. And then I say here's some extra data on the students, which this is where I call that function calc extra info, passing in the table that I was using with all the data in it, and assign it to a variable called extra info, which I then print. And what extra info is actually another table where it shows the maximum and average of each of the different scores. So let me go up there and just show you this last little piece. It's called calc extra info. And it takes in a table essentially, or matrix is what it is. There's tables and matrix, but basically the same thing. So it takes in a table or a matrix, whatever. So that was that one that I've been creating and using for all the calculations as we go. So I got the number of columns, and that you can get by incall, which is number of columns function of the table, but I'm subtracting 2 because I actually added 2 more that weren't in the original file, because final exams here, then I made a total points column and then a letter grade column. So there's 2 that I added, so I'm not worried about those because they don't affect this calculation. So I'm subtracting 2 manually, and then I'm getting number of rows, which actually is not necessary. So again, some on the fly editing, forgot to take that out. That's not important. So then I'm going to create a table that I'm going to actually return from this function, and it's going to so again store the maximum and average of each of the OLA, quiz, and exam, final exam. So where was I? So I set up a brand new matrix is what I'm using, with 2 rows because it's just going to be a max and average, and the number of columns -1. I'm -1ing here because I'm actually so I've already trimmed off the 2 that I added. So 1, 2, 3, 4, 5, 6. So there's 6 columns here, but the C number I'm not interested in. I'm just interested in the maximum and average of these 5 values here. So I'm subtracting 1 from the number of columns value that I got here. Already subtracting the 2. So here's the extra one, the M number or C number that I don't need. So I have this empty matrix with the exact dimensions that I want. Then I'm going to set some this is a cool thing. You can name your rows and columns, which don't affect the data, but just again prints pretty. And I actually did that at the very beginning when I had that weird parameter, and it read in these as the column name, C whatever. Okay, and so I make a little actually use another matrix because it wants a matrix or some sort of list, or it wants a matrix with the number of elements that are associated with each. Like when you assign row names, you have to have a matrix with 2 elements because I have 2 rows, right? So I make another matrix here called row title, setting maximum and average as the title of the rows, and then I can set when I call the row names function on the return table, I can just set that row titles matrix to those row names. And the same thing with the column titles. So again, only 5 that we're interested in: CLA, LA, quiz, exam, final exam. 1, 2, 3, 4, 5. Yeah, okay. And set call names on the return table to this matrix of call titles. Okay. So we got our titles for our return array across the top and on the side. And now we're going to go through the number of columns and again do what R is good at, which is matrix math, one-line matrix math. So we go through, we start with 2 because again, I'm not interested. They don't index. Sorry, I didn't say this earlier. R doesn't index with 0. It starts at 1. So we want to start at 2 because again, we're not interested in this first column. We want to iterate through each column here, starting at 2 and going through the number of columns, which I've already taken those 2 off, so we're good here. Then I'm just going to call the max function, put it in a max variable of the ith column. Again, if you leave the first parameter here empty, it just says I just want the column. And this little dumb parameter is I forgot. There's some special case where you can set true, but it really doesn't matter. The output will be the same. There's all these weird parameters. Okay, so you get the max of column 1, and then I'm going to set it in the return table, and I have to make a tiny adjustment I-1 here to compensate for the row titles. And then I use this format thing to round it to essentially 2 digits. Because when it starts doing these max and average stuff, it just starts throwing them into floating point format, and I just didn't like them. I wanted it to be pretty, so use this. Comes out of strings instead of integers, or doubles or whatever, but it's okay. So they look good. So anyway, max of the column, and then the average you can just call the mean function the same way on the ith column, and then input it into the correct element of the return table, formatting with 2 digits, rounded to 2 digits, 2 decimal places, sorry, and then return that table, which we just print down here, and then that's it. Okay, sorry, that's pretty long. Okay, so let's run this thing now. Go to the IDE or whatever. So here we are at this command thing. So what you can do here is I think it might be different on the one. I think it might be the first one. You can click this one and it says R file source to load. So you can actually browse to the file and just double click it and open it. I have just, pressed it enough. I have it saved in the recent memory, so this is where it happens to be on my thing. So even if you double click it like that, browse to it and double click it, all it's going to do is populate and run this source command, and it's just source method and then a string of the file path to the R script. Hit enter, and then you start executing immediately. So it's going to ask for the full path here of wherever the scores file is, and I think I've got that all the way up here. Yep. Okay. So for me, it was this. It was in the same folder, but whatever, you'll just put wherever it is. Hit enter, and the C number of the student you wish to view. Okay. Let's use this thing because I don't remember them. So we input 1, and then it prints out just an object. And this is what happens when you just print an object. It says this is an object of class student, and it uses these things called slots, which is what they call properties essentially. That's like the generic term. You can set slot. I think there's a set slot method or whatever. But the property name and the value for each one of these. And then it's going to ask for another one, so we'll give it another one. How about this one? Okay, so actually immediately after that second one, I execute the rest of it. So let me get back up here to show you that it did another one. That's a lot of students. Okay, so there was the first one. Here's the second one. Another is a different one. As you can see, this one's 507, this one's 517. The values are different. This guy has a C, this guy has a C minus. But here's all the stuff. Here's all the object data. And then I said, here are the rest of the students. Okay, and when you actually print a full list, it's cool because this first value is the key that's associated with, again, it's associative array. So this is the key, which happens to be the same as student ID, but it shows you that here's a key value pair, or here's the key, and then the value is this whole object here. And again, there's a whole bunch of them. We'll go down letter D, B plus, C. They're all different. You can stop and pause if you want to go through them all, but here they all are. And then at the end, real quick, I just wanted to show you, actually I don't like this right. At the end I just want to show you how cool R is if you don't mess with OLP. So here's the table that I was actually working with and building as we went. So so when I first call that first read file, let me show you again. That one line at the very beginning, input data, which is my main table that I'm working with, read.table, the file name, input, and then these weird little parameters. I think this is one that has tons of them that you can put in there. That got me essentially this whole table minus these right two columns. So I added these two columns, but you end up with, I can't highlight just that, but from here over to the final exam column, ready to go, ready to manipulate. So it's super fast and ready and good to go. So anyway, here's that total points column that we calculated, and that's just the sum of each row minus this, and then the letter grade is from the function that or the method that we wrote. And then here's the extra data down here. As you can see, here's the name of the columns that we set, and the name of the rows, maximum and average, and then, like I said, that format where it rounds to 2 decimal places turns them to strings for whatever reason, but at least they're not, I think it was like 5 or 6 digits precision, and it was just ugly to me, so I did it this way. But these are the CLA, LA maximums, and then average from each one of the columns, and that is R. And I think I said it all, and yep, that's it. Thanks, Dr. Don.